Hello everyone, my name is Richardson A from the Department of Artificial Intelligence and Data Science at the third year. So I'm from Savita Engineering College where today I'm going to represent about my mini project. Title is AI Embedded Self-Balancing Robot for Interactive Experience. So my team members are Kishore Kumar U, Harish G and myself Richardson. So let us go to the introduction part. So the introduction part is significance of autonomous system. Standing self-balance robots are critical advancement in the field of robotics, combining mechanical engineers and computer science and artificial intelligence. So the traditional robots, unlike robots that rely on external supports or fixed based and self-balancing robots are designed to autonomous maintains balance and stability. There are few key components. These robots use to advanced sensors, control systems and algorithms to adapt to various environment and tasks. Visibility in applications. Self-balancing robots are capable of performing a wide range of tasks from household chores to complex industrial operation. Technology milestones we had, the development of self-balancing robots pushes the boundaries of autonomous system, contributing to more versatile and intelligence robotic solution in both daily life and industrials. So this is about the introduction. Let us go to the problem statement. So the problem statement is designing a robot that can autonomously stand and balance there itself and moving in variety of environment present. A significant engineering challenge is, unlike stationary or external supports robots, a self-balancing robot must maintain its stability its own, which requires advanced real-time decision making and control mechanism. The robots need to adapt to different surface, handle unexpected obstacles and recover from the potential disturbance without human involtion. Achieving this level of autonomy involves solving complex problem in sensor integration, control algorithm and mechanical measurements that robots can functionally reliable in the real-time world settings. So this is about the problem statement. Let us go to the scope of the project. Scope of the project where the development and functionality and applications we are going to see. So about the development, designing a prototype and self-balancing robot capable of basic movement like waking and standing there itself. So the functionality we had is implementing a real-time balance control environment, interacting using sensors and balance user interface for monitoring and control. So the applications are focusing on industrials and home assistance appliances. So the limitations, technology sensors accurately high energy consumption and processing power concentration. So the environment we had is challenging on uneven slippery terrains and in the traditional conditions. So the development and maintenance cost and potential challenges is very high. So let us go to the electrical diagram and 3D model. We are having a model of our project, which is shows in the PPT. So there are few components which helps to work and stand there by itself, and there are few programming languages where we used PID programming, and the equipment we were used is Arduino Nano MPU605 gyro sensor, which is used to self balance there itself, and NEMA 17 stepper motor where we used in tire to move in a variety of areas, and a 100 wheel where the stepper motors are connected with the wheel, and A4988 stepper devised IC, the IC, and HC05 Bluetooth module, acrylic sheet which is the frame of the robot, and 20 centimeter M5 threaded rods which is the chassis of the robot, which holds the whole part of the robot, and some nuts. So let us talk about the uh, components where we used in the robots. So Arduino Nano. Overview: a small compact microcontroller based on the AT Mega 328, similar to Arduino Uno but smaller, in the size of smaller. There are few features in this microcontroller. So the microcontroller uh, name is 80 Mega 328. Voltage of 5 voltage, 7 to 12 voltage input, where it gets the 7 to 12, around from 7 to 12 it gets the input. And digital pins, 14 pins we were using, and 6 PWM. Analog pins are 8, and clock is 16 megahertz, and size of 18 into 45 mm. So this Arduino Nano can used in various applications like IoT, uh, wearables, sensors and robots. Advantages are high precisions and control and reliability. So let us go to the next component, which is MPU 605 gyro sensor. So these gyro sensors are a 6-axis motion tracking device, which is a gyroscope and accelerometer used to measure orientation and movement. So there are few features in this gyro sensor. A gyroscope, a gyroscope measurement radiation is velocity of analog x, y, and z axis. There are three axes. So accelerometer measures acceleration g along with x, y, z axis. So there are few applications like drones and robots and smartphones, gaming controller. So in these applications we can use this gyro sensor, and there are few advantages for this: precision motion tracking and small in size and low power consumption. It takes very low power consumption. So let us go to the motor we were used in our robot. So the name is NEMA 17 stepper motor, 17 stepper motors. Overview: the motors, a motor standard in size stepper motor, 1.7 into 1.7 inches, widely used for precision motion control. There are few features. Torque is 30 to 70 newton centimeter. So the stepper revolution is 1.8 degree per second per step, a 200 step for revolutions divided by revolution. There are few applications like 3D printers, CNC machine, and robotics, where we can use this. Commonly the stepper motors are used, and there are few advantages like high precisions and durable design and easy to control. These stepper motors are very easy to control in several applications. And let us go to the stepper device IC. So today, so the stepper device IC is a micro stepping motor device IC used to control bipolar stepper motor, offering the precision movement control. There are few features in this stepper device IC. Micro steppering supports full, half, and step modules 1 by 16. Max output is up to 35 voltage and 2 ampere per coil. So the protection: overcurrent and thermal stand down, and under voltage lockout. So the applications where the stepper device are used is CNC machine and robotics and automations. There are few advantages for the stepper device: smooth in control, compact in design, and built-in protection. And let us see the Bluetooth module HC05. A Bluetooth module is used to wireless communication between the device and supports spiral communication over the Bluetooth. There are few features. Bluetooth version is 0.2 plus EDR, and the range is up to 10 meters, and the module is master and slavier module. But rate is 9600 default, as it is a default thing. And the applications is robotics, automations, and microcontroller communications. Advantages are easy to pairing, low power, reliable connections. These are the advantages. So let us go to the learning from the projects. So what we learned in this project is balancing control, prototype challenges, and sensor integration. These are the So this balancing control is were used in a self-balancing AI robot. So we gained a deep insight into the complexity of designing an algorithm for real-time balancing and stability in dynamic environments. So these are the balancing control. So prototype challenges we had: understanding and understood the particles difficulties of the transition from simulation to real world testing, introducing including the unexpected opticals and environment factors. Sensor integrations are learning the importance of scaling and celebrating a sensor's environment, participation and movement. So these are the things we were used our projects, the components and mechanically and AI used programs, and we were used to implement these projects. So at the conclusions, addressing a key challenge in automation and robotics with advantage technology, leverage species control algorithms and sensor integration for automation, balancing navigations, centralizing central data, improving operational efficiency and providing real-time solutions. So advanced robots capable to contribute to technology involvement and participation automations. So these are the conclusions of our project. So we had the several reference like J. Smith, Brown and L. Wong advanced control algorithms for self-balancing robot in dynamic environments. So they are the International Journal of Robotics Research, and another reference are R. Johnson, T. Lee, and M. Patel. There are the real-time sensor integration and balancing maintenance in the autonomous robots in IEEE transactions on robots. So another reference is H. H. Devious K. Navigin and S. Green, enhancing robot mobility and stability. A review of recent advanced robots and automation magazine. So these persons where we took a reference for our projects. So at the conclusion, our project is implemented successfully, which is very difficult and hard to implement our project by coding. So we had lots of challenges to complete these projects, and thank you so much for giving opportunity to speak about my mini project where we successfully completed. Thank you so much.